Okay, continuing with simultaneous equations, but this page has some slightly different ones. In the page above, we were just subtracting our equations because we had the same coefficient of one of the variables each time. So they were just ready to subtract. Even when the coefficient was both negative, it would eliminate itself when we subtract. On this question, you may notice that, again, we have the same coefficient of one of the variables, so not the r's in this case, but the s's. However, one of them is positive and one of them is negative, which wasn't the case on the previous page. So let's have a look what would happen if we tried to subtract here. So if we did equation 1 take away equation 2, what would we get? Well, 3r take away r would give us 2r, and 4s take away negative 4s, I'm just going to write it up here, I don't know why this is lagging, that would actually give us 8s, because this subtract a negative at the top could be turned into a plus. Okay, so we wouldn't actually eliminate one of our variables, and that would be 26 at the end there. So we've still got one equation, two variables, therefore impossible to solve on its own. So what else could we have done? Get rid of that. Okay, well, how do you eliminate a variable when they are the same, but one's positive and one's negative? Well, try adding them together. Let's see what happens here. So if we add 3r and r, we're going to end up with 4r. And if we add 4s, positive 4s, to negative 4s, so I don't know why this is lagging, they're going to cancel out, because when we add a negative, it's the same as subtracting. So that's worked this time. When we add 23 and negative 3, we're going to get 20. And then we can solve that from there. So r must be 5. We've got our first solution. We're going to sub that in to either of the equations, but I try to make it as easy as possible if I can do. For example, I wouldn't substitute this into equation 2 because then my s is already negative. I would substitute into equation 1 here, even though I've got to then multiply it. So 3 lots of r would be 15. Oops. Plus 4s is 23, and then you've got that little equation to solve there. So take away 15. 4s must be equal to 8. Divide by 4. And we see that s must be equal to 2. Okay, so basically on question 3, add together. And you probably noticed by now that it doesn't matter whether it's this variable, this first one, where your coefficients are the same, or if it's the second one. Okay, so these questions have a mixture of it being the first or the second. Okay, pause the video here and then press play and I'll show you the answers to the rest of them. Okay, there's the answers to the rest of question 3. These are, remember, uploaded as PDF. We'll just spotted an error on this one. That should be W over there. Whoops. Here we go. Okay, on to question 4. Question 4 introduces us to the first sets of simultaneous equations where we don't already have the same coefficient in front of a pair of variables. So we don't have the same number of e's, we don't have the same number of f's, even if we consider one being positive, one being negative. And in this case, we're going to have to change one of the equations so that we do one or both of the equations, that is. But I think for these first ones, we just need to change one of the equations. So how could I get the same number of e's? Or how could I get the same number of f's is what should be going through your head right now. The e's would definitely be easier in this case because I could just double the first equation, and that actually reminds me I should label these equations, and I'm going to double the first one. So when I double 2e, that becomes 4e. If I double the 3f, that's going to become 6f. and if I double 17, that's going to become 34. And this we'll call equation 3. Even though it's technically the same equation as equation 1, we're just going to call it equation 3 for now. Okay, now if we just look at equation 3 and equation 2 and ignore equation 1, we can see that we've got 4e in both equations. And now we can eliminate the e's. They're both positive, so we're going to subtract. One little thing I've heard to help remember that is same sign subtract. So if you've got two things at the same sign, both positive or both negative, subtract them. If they're opposites, you add them. So we're going to subtract. We're going to do equation 3 take away equation 2. So 4e take away 4e would be 0. That's what we wanted to happen. 6f take away 2f is 4f. And 34 take away 30 is 4. So therefore f is 1. And then we're going to sub that in to any of the equations, 1, 2 or 3. Where would we have to do the least to it? Well, it doesn't really matter, to be honest. Let's go with equation 2. So 4e is still what I don't know. 2f would be 2, because f is 1, and that's equal to 30. Probably by this point you've done tons of solving equations, so this bit's probably optional, showing all your working here, as you would do previously on a solve an equation question, but it's not a bad thing to show you working. So E is 7, and there we've got our two solutions. Okay, just a little hint on the next one. Go for the G's, try and make the G's the same. And on question C, try and make your J's the same. Okay, just watch out for negatives. Okay, pause the video here and I'll show you the answers. Okay, there's the other answers to question 4. And let's move on to question 5. Okay, on question 5, you might have guessed what the difference would be on this question. On the previous one, we only had to change one of the equations to make a couple of our variables the same. In this question, we have to change both of our equations. So let's call this equation 1 and this one equation 2. I can't multiply this by 2 or whatever to get 3. I mean, I could times it by 1.5, but that could get messy over here. And I can't do anything to 3 to easily turn it into 4. So I'm actually going to times these both by something. And I could go for 6k or I could go for 12l, but the point is I want to try and make a common multiple of these two numbers. Okay, and I'm going to go for the k's being the same. I want to try and make 6k, so I need to multiply this first one by 3 and the second equation by 2. So that would give me 6k. If I multiply the 3l by 3, that would give me 9l. Whoops. And 7 times 3 is 21. Okay, and I'm going to call that equation 3. Now I'm going to multiply this by 2 and get 6k. If I double the 4l, I'll get 8l. And if I double 10, I'll get 20. And I'm going to call that equation 4. And now I'm just going to be focusing on these two equations and forgetting the first two for now. So to eliminate the 6k's, they're the same sign, they're both positive, so I'm going to subtract. And I might as well subtract 4 from equation 3. So just going to tell the marker that that's what I'm doing. That will eliminate the k's, that will leave me 1l, and that will leave me 1. So nothing to solve there. It's ready to substitute in. Doesn't matter where I put this. I'm going to put it into equation 1. So you can go back and use the old original equations to substitute into, that's absolutely fine. So 2 lots of k plus 3 lots of 1, or 3, is equal to 7. Nice easy equation there to solve. Subtract 3, and that will give us 2k equals 4. Divide by 2, and k is equal to 2. Okay. You can still multiply both equations and then do the adding method to eliminate variables, so just keep an eye out for that. Okay, give them a go and I'll reveal the answer in a second. Okay, here's the answers to questions B and C. I did actually add these two together because I went for making the n's the same, which is slightly easier I thought than making the m's the same. But the other two I used subtractions. Okay, To avoid making a really long video, I'll go through the next page on a different video.